This is Oberon. It's the second largest moon of Uranus and is one of the 5 major moons in the Uranian system. With a diameter of just over 1500 kilometers, this moon made of ice and rock is 2.5 times smaller than our own moon and completes an orbit around Uranus in 13.4 days. Using a telescope he built himself, William Herschel discovered Oberon on the 11th of January 1787, the same day he also discovered Titania, the largest Uranian moon. Nice. This is quite fitting really, because it was Herschel who also discovered Uranus 6 years earlier. Herschel's telescope was so good at finding distant moons, it would be another 50 years before Oberon and Titania would be spotted again using different equipment. If the name Herschel seems familiar to you, it really should, because this German-born part-time musician was a telescope prodigy. He built the infamous 40-foot telescope found in the UK, and the ESA named their revolutionary space observatory after him, not to mention all the various craters and asteroids that also share a name with Herschel. Speaking of names, Oberon is named after the King of Fairies from Shakespeare's A Midsummer Night's Dream. This follows the pretty loose and poorly adhered to trend of naming Uranian moons after Shakespearean characters. Almost 200 years after it was discovered, Oberon was finally seen up close when Voyager 2 flew by Uranus, snapping photos of the known moons as it zoomed past them while also discovering some new ones while it did so. This image of Oberon was taken from 660,000 kilometers away and is the best image of the moon taken to date, one that captures many of the Oberonian surface features. As you can see, the surface is covered in craters, some of which are even big enough to warrant names, such as Othello, Hamlet and Macbeth. I'm spotting a theme here. Using additional onboard camera filters, the actual colour of Oberon could be reconstructed, unveiling a reddish tinge across the surface of the moon. To a certain degree, all 5 of the major moons of Uranus have a shade of red on their surface, although the leading hemisphere, i.e. the half of the moon facing the direction of its orbit, is much redder than the trailing hemisphere, the other side of the moon. There's a trend at play here too, where the further out a moon is from Uranus, the redder it becomes, with Oberon being the reddest of the lot. So why is Oberon the reddest of the major Uranian moons? First, let's take a look at the 9 irregular moons of Uranus, which are much further out and orbiting in the opposite direction to the Big Five, i.e. in a retrograde direction. Using photometry, a technique used to measure the various parameters of light emitted from objects in space, astronomers have determined that all 9 irregular moons are much redder than the Big Five that orbit much closer to Uranus. Because these irregular moons are so far away from their parent planet, they will be bombarded by solar wind, whereas the inner moons are essentially shielded by the magnetosphere of Uranus. A combination of solar wind and micrometeorite impacts on these outer moons will kick up a ton of dust into space. Now these impacts will throw the dust way out of the gravitational influence of the smaller moons, but not far enough away to escape the gravity of Uranus. This means a cloud of reddish dust is always raining down on the gas giant and its inner moons. Since Oberon is the furthest out of these major moons, it will encounter the reddening first before the cloud continues inwards, but with less of the red dust available to coat the moons closest to Uranus, thus explaining why Oberon is the reddest of the major moons of Uranus.